In this video, we are going to look at how to find a derivative of tangent of angle theta from first principles. Now don't forget that if our y is equal to a tangent of angle theta, is that okay? Then we shall say a small change in y is equal to a tangent of theta. We increase a theta by a small change in theta minus a tangent of theta. Is that okay? Now we shall expand this tangent of theta plus a small change in theta, and we shall have a small change in y as a tangent of theta plus a tangent of small change in theta out of a 1 minus a tangent of theta times a tangent of small change in theta minus a tangent of theta out of a 1. Now from there we are going to expand and we try to factor out some things. So a dy dx will be equal to, now we get the LCM, and it's 1 minus a tan of theta, a tan of small change in theta. Is that okay? Now we get this denominator, we divide by the denominator, we shall get a 1 times the numerator, we shall have a tan of theta plus a tan of small change in theta, minus we get 1 minus tan of theta times small change in theta, divide by 1, we shall get the same result times tan theta, so we shall have tan of theta into 1 minus tangent of theta, tangent of small change in theta. Now upon expanding, a small change in y is equal to a tangent of theta plus a tangent of small change in theta minus a tangent of theta plus a tangent squared and a tangent of small change in theta divided by 1 minus a tangent of theta, a tangent of small change in theta. Now tan theta and tan theta will cancel and we shall have a small change in y. We shall have a small change in y as a tangent of small change in theta. We shall factor it out and we shall have a 1 plus tangent squared of theta divided by 1 minus a tangent of theta, tangent of small change in theta. Is that okay? Now we should note that for small angles in radians, tangent of small change in angle theta is just approximate to a small change in theta. Now to visualize this, we shall make sure that we let our small change in theta as a 0.005. So we shall say assume a small change in theta to be approximate to 0.005, and we shall place our calculators in radians and we substitute a change in theta in a tan and we find the result. So this is 0.005 is approximate to tangent of 0.005, and the result is 0.2 zeros, and we have a 5 plus other 4 zeros, then a 4, 1, and this is just approximate to 0.005. Therefore it is true that a tangent of small change in theta is approximate to a small change in theta. Therefore we shall say a small change in y is equal to a small change in theta out of into 1 plus a tangent squared of theta out of a 1 minus a tangent of theta, tangent of small change in theta. Then we shall divide by a small change in theta on both sides, and this small change in theta will cancel with that small change in theta. We shall have a dy a d theta is equal to 1 plus a tangent squared theta out of 1 minus tangent of theta. This was small change in theta. Is that okay? Now we shall find the limit as d theta tends to 0, a small change in y out of small change in theta, and we know that this is just approximate to a dy out of a d theta. Is that okay? So we shall continue by saying a dy d theta is equal to a limit as a small change in theta tends to 0 of 1 plus tan squared theta out of 1 minus a tan squared, a tan theta times a small change in theta. But don't forget that as a small change in theta tends to 0, so we shall have a dy d theta to be 1 plus a tan squared theta out of, this guy will go to 0 because we shall have a 0 times a tan theta, so which is a 0 divided by a 1. So a dy d theta is equal to 1 plus a tan squared theta. But this identity in trig is the same as saying sec squared theta. Is that okay? So a d theta over tan theta is equal to sec squared theta from first principles. Thank you for watching. Don't forget to subscribe, like the video for more about mathematics.